What if building your own humanoid robot was as easy as printing a file and screwing parts together for under $5,000? And what if robots could not only walk, but dance, flip, and break it down better than a seasoned b-boy? This is no longer science fiction. Today, we're diving into two jaw-dropping breakthroughs in humanoid robotics. UC Berkeley just unveiled an open-source humanoid that anyone can build for a fraction of the cost of commercial bots. It walks, it writes, and it learns through AI. Meanwhile, Boston Dynamics' Atlas robot is pulling off dance moves so smooth, viewers thought it was a person in a costume. It's not. From DIY humanoids to robots trained like pro athletes, this is your front row seat to the future of robotics. Let's start in California. UC Berkeley's HybridRobotics lab just introduced a project that's making robotic research radically more accessible. It's called the Berkeley-Humanoid-Lite, and it's shaking up the industry by doing what no commercial robot ever dared, being open, printable, and affordable. This humanoid robot can be built for under $5,000 using 3D printed parts, basic aluminum, and off-the-shelf electronics. We're not talking about a toy. This is a fully functional AI-powered humanoid that can walk, write, and learn new tasks through reinforcement learning. The same kind of learning used to train some of the world's most advanced AI models. At the heart of the robot are 22 cycloidal gear actuators. These parts are 3D printed to reduce cost while still maintaining precision. The rest of the body, designed to be printable using a standard desktop 3D printer with a build area of just 200 millimeters. But here's the game changer. All of it, the files, the CAD models, the training code, the assembly instructions, is completely open source, available right now on GitHub. That means researchers, students, and hobbyists can study, build, modify, and improve the robot on their own terms. You want to add a gripper? Swap the legs? Train it to play chess? You can. And the learning system? It's built for real-world application. By using simulation environments first, the robot can master skills virtually, then apply those skills to its physical body in the real world. This method, known as sim-to-real transfer, is one of the most efficient ways to train AI agents in robotics today. Berkeley-Humanoid-Lite isn't just a research tool, it's a launch pad for innovation. And at a time when humanoid robotics is dominated by high-cost closed systems, this project is flipping the narrative. It's grassroots, it's community-driven, and it's a bold reminder that the future of robotics shouldn't be locked behind a paywall. Now, on the other end of the spectrum, we move from open source to elite performance. Boston Dynamics has just unveiled the latest version of its iconic humanoid robot, Atlas. And this time, it's not walking or lifting boxes. It's breakdancing. In a recent showcase, Atlas performed a routine that included full cartwheels, fluid coffee grinder spins, and transitions so natural, people online assumed it was a person in a suit. It's not. This is pure robotics, trained using motion capture data from real dancers and powered by reinforcement learning. It's not choreographed, it's learned. A new Atlas is fully electric, no hydraulics, and it's lighter, more agile, and more expressive than any previous version. With 28 degrees of freedom, advanced laser vision, and real-time motion planning, Atlas is pushing the limits of what robots can physically do. And it's not just about entertainment. Breakdancing requires dynamic balance, microsecond timing, and precise foot placement. Achieving this in a humanoid robot means mastering some of the hardest challenges in movement science. Think about it. To swing a leg, shift weight, rotate mid-spin, and stick a landing while adjusting in real time to environmental feedback, that's next-level robotics. But how does it learn? The training process combines motion capture with layered reinforcement learning. That means human dancers first perform moves while wearing tracking sensors. The robot then uses those motion blueprints to train its neural networks through trial and error, adapting until it achieves similar results with its own body. And it works. So well, in fact, that Atlas doesn't just mimic movements, it owns them. Boston Dynamics says Atlas isn't for sale, at least not yet. But the vision is clear. This level of coordination and adaptability has huge implications for real-world use, from disaster response to warehouse logistics and manufacturing. In any environment where agility, balance, and human-like motion are valuable, robots like Atlas could be game changers. But here's what's even more exciting. These two stories, Berkeley's open-source bot and Boston Dynamics' dancing machine, are happening at the same time. One makes robotics radically accessible. The other pushes robotics to athletic extremes. And together, they tell a story. Robots are no longer confined to factories, labs, or distant futures. Entering classrooms, garages, YouTube videos, and talent shows. They're teaching us how to walk again and showing us how to dance. From DIY to AAA robotics, the field is expanding fast, and everyone can have a role in shaping what comes next. So, are you ready? To build your own humanoid, to train it, test it, or maybe even choreograph it. Because this is the future, and it's not waiting. This is AINN. See you in the future.